Hi, good morning to all. Welcome to the today's session on rolling contact bearings introduction. Myself, Professor Prashant Kushare, welcomes you to today's session on introduction to rolling contact bearings. Learning objective of the today's session: define bearing and explain different types of rolling contact bearing. After this session, you can easily define bearing and explain different types of rolling contacts bearing. Let us see what do you mean by bearing, their classification and materials used for bearings. Let us define bearing. Bearing is a machine element or a mechanical element that permits relative motion between two parts. Two parts means that is shaft and the housing with a minimum friction and prevent unwanted motion. That means it permits relative motion between the two parts and prevent unwanted motion, but how it is achieving it with a minimum friction. And this machine element or a mechanical element is known as a bearing. The functions of the bearing. The bearing permits free rotation of the shafts or the axle. Bearing supports the shaft or the axle and maintain its correct position, and it take up the forces and transmit it to the foundation. That means it also carries some load. These are some of the important functions of the bearing. Along with this, you can add it to minimize the friction or a wear also. Classification. Bearings are classified in different ways depending on the direction of load. Now here you can observe here. So we are going to classify bearings based on direction of load acts on it. So generally you know very well two loads which are coming on the shafts or the parts which are radial and thrust load. And based on that, bearings are classified into two types. One is the radial bearing, the second one is the thrust bearing. What do you mean by radial bearing? Radial bearing supports the load which is perpendicular to the axis of the shaft. That means it's a radial. Look at this. It's a shaft. Again, here you will find it's a bearing part, then it's a housing part, it's a inner race. This part is a rolling element. This is the outer race. This is also outer race. And here load P which is X on it. It supports the load which is perpendicular to the axis. Look at this. This is the axis. Load is perpendicular. It's a radial load. The bearing which supports the radial load or load which is perpendicular to the axis of the shaft is known as radial bearing. Then second one, thrust bearing. Again here in thrust bearing, look at this. It or this bearing supports the load which acts along the axis of the shaft. Look at this, you will find this is the axis. Here this is the frame. Here this is the bearing. Again here the balls are pitted. Here the rolling elements or the thrust ball bearing. And here load P which is X. But here the load which acts along the axis of the shaft, generally we are stating it as a thrust or a axial load. The bearing which support this load which acts along the axis of the shaft. This bearing is known as thrust bearing. And you know very well, thrust bearing also consists of balls running between the two rings, that is shaft ring and the one is the shaft ring and another one is the housing ring. Again here this ball bearing carry thrust load in one direction only, try to understand. It cannot carry any radial load. If these are the major advantage, the high thrust load carrying capacity in smaller space is a main advantage. But what are the some of the limitations to thrust bearings are? It can't take any radial load. It's not a self-aligning bearing or cannot tolerate misalignment. Then at a high speed, such a bearing gives poor service. That means it can be used for a low or a medium speeds. And why it gives a poor service? Because of centrifugal forces which are going to induce at a high speed. Again here, it's required here continuous pressure applied by springs to hold the rings together. That means maybe frame or the two rings that I have already stated, the shaft. And because of that, it can as the thrust load. This is about the second classification based on the load thrust bearing. Now another classification based on the friction. You know very well, based on the type of friction between the shaft and the bearing surface, there are two classification. One is sliding contact bearing and another one is the rolling contact bearing. Now here sliding contact bearings are also known as plain bearing, journal bearing or sleeve bearing, and rolling contact bearings are also known as anti-friction bearing or ball bearings. Depends on the whether the rolling element is a ball, you can say it as a ball bearing. If it's a roller, you can say roller contact bearing. Now let us see first one, sliding contact bearing. Now here in sliding contact, look at this here. This is the shaft. In between there is, I have shown one gap, then bush, and this is the part of the bearing. Why the gap is provided? To provide or supply the lubricant. How it is going to work, I will explain. The shaft slides. This shaft slides over the surface of the bush, this bush, resulting in friction and wear if there is a no gap. Directly the shaft at initial stage or position, shaft directly comes in contact with this, and because of that, when shaft is going to rotate, there is a friction. But how to prevent or reduce this friction? The lubricating oil is used here and the bush, and when lubricating oil is used, it reduces the friction between shaft and the this bearing part. Again here this bush is provided, which is made up of a special material, that is white metal or a branch. This is sliding contact. Why the name is used here sliding? Because there is a the sliding contact between the shaft and the bush or the bearing. And such a bearings are used in crankshafts, in petrol and diesel engines, centrifugal pumps, large size electric motors, steam and gas turbines, concrete mixtures, rope conveyors, and marine installation. Sliding contact bearing. This is one classification based on friction. Another classification, rolling contact bearing. You know very well, as earlier stated, rolling contact bearing is also known as anti-friction bearing or simply ball bearing. Why it is known as anti-friction bearing? Because initially, during the starting, there is a friction, but during running condition, it is going to reduce. And compared with the sliding contact bearing, it's less. That's why rolling contact bearing is known as anti-frictional bearing also, or anti-friction bearing. And here you know very well the rolling, look at this here, rolling contact bearing, it consists of, here this part is known as a bore diameter to insert the shaft or a journal. Journal means the part of the shaft which is inserted in the bearing is known as the journal. Then this part is the inner race, this part is the outer race, in between inner race and outer race. Here all these are the rolling element, and these rolling elements are held together by using a cage. So here parts of the rolling contact bearings are inner and outer race. This part is inner race, this part is outer race. Then rolling element may be ball, roller or needle. Look at this here, rolling element. Then cage which is used to hold the rolling elements together. In between here you will find how these balls are held together by using a cage. Try to understand. Then here the rolling contact bearings are used in many applications such as machine tool spindles, automobile axles, then gearboxes, electric motors, rope sheaves, crane hooks and hoisting drum. These are some of the application of rolling contact bearings. Now let us see the classification of rolling contact bearing, because in this module our focus is on rolling contact bearing only. That's why based on this we are going to classify here only rolling contact bearing. Now rolling contact bearings are classified based on the types of rolling element. That means here as stated, it consists of inner race, outer race and rolling element. The rolling elements decides the type of bearing. Now based on the rolling element, rolling contact bearings are classified ball bearing, cylindrical roller bearing, taper roller bearing and needle bearing. Taper roller bearing I will explain on the separate section, design of what do you mean by taper, selection procedure of taper roller bearing from manufacturer's catalog. In this session I will elaborate and explain ball bearing, cylindrical roller bearing and needle bearing. Now here, look at this here, ball bearings. The rolling element is a ball. That's why it's a ball bearing. In this case, cylindrical roller. Here, cylindrical, instead of a ball, cylindrical roller construction, which is a of a rolling element. And third one is the taper roller bearing. This rolling element is having a taper. So based on this, the classification of the rolling element ball, cylindrical, and taper roller. Needle bearing means again here it's like a roller bearing, but the length of the bearing which is more than the diameter of the roller. Try to understand. And it looks like a needle. That's why name is given needle bearing. Now let us see another classification, angular contact bearing. Now angular contact bearing here, the grooves in, look at this here, these are the balls actually, but the arrangement is made in the grooves of the inner race and the outer race. Because of this, what is going to happen, that is very important. Grooves in this inner race and the outer race are so shaped that line of reaction here, line of reaction at the contact between these balls at the outer race and the inner race makes an angle with the axis of the bearing. This is the axis of the bearing, and because of this, it makes an angle, and this angle is known as the contact angle. And because of this, what is going to happen here? Because of this inclination or contact angle, you will find two component. One is the radial component, and one is the axial component. And therefore, angular contact bearing can take radial as well as the axial load. Therefore, angular contact bearings are used in pairs because of radial and axial. But while using it, they may be used either side by side or at the opposite ends of the shaft. Directly side by side means near to, or otherwise at one end one bearing, another end another bearing. And again here, it takes the thrust load in both the direction. Try to understand. The line of action, as I have mentioned, the line of action of the load that is at the contact between the balls and the inner and the outer legs makes an angle with the axis of the bearing. This angle is known as the contact angle. And because of these two components, radial and axial, and that's why suitable for combined radial and axial load. But what are the limits? This is the major advantage. It can take radial and axial load, but having some limitation because we can't use a single bearing. Two bearings are required. This is the limitation. Because of this, cost is going to increase. Second, angular contact bearing must be mounted without axial play. Otherwise, the component may going to change, and it requires initial preloading. These are some of the limitations of angular contact bearing. Now let us see cylindrical roller bearing. Now here in cylindrical roller bearing, the point of contact of the bearing in case of ball bearing is replaced. Now here in case of ball bearing, look at this. There is a point of contact here which is replaced by the line of contact of the roller. That means it's a roller. So instead of having in a ball bearing, you will get a point contact. Here you will get a line contact. So in the cylindrical roller bearing, this point of or point contact is replaced by line contact. And because of this, radial load capacity is going to increase, or it can take very high radial load. And cylindrical, again compared with the ball bearing, cylindrical roller bearing is more rigid, and coefficient of friction is low, and friction losses is less in high speed applications. And because of this, you will find cylindrical roller bearings are used in machine tool spindles, locomotive vehicles, IC engines, and roll mill, etc., where is a heavy duty radial load which is acting on it. Again here the but is having some of the limitations. These are, it can't take a thrust load, it's not a self-aligning bearing, cannot tolerate the misalignment, proper precise alignment is required while mounting, and more noise. These are some of the limitations compared with the other type of bearing. The next one is the self-aligning bearing. Self-aligning bearing means as the load is going to change accordingly, the bearing which is going to align. Now here there are two types of self-aligning bearing. One is the self-aligning ball bearing, and second one is the self-aligning roller bearing. Look at this here. In this case, these are the balls, but here the curvature which is provided on the bearing part, accordingly the inner space, this space is going to tilt here. Look at this in the another diagram. You will find the arrangement, the curvature is provided in such a way that the shaft or the journal, when if there is a misalignment, it can accommodate in this way in the bearing. Similarly, in case it's a self-aligning ball bearing, but here say spherical roller bearing. Look at this shape to the given to the bearing part, as well as the balls also accordingly can shift or the tilt inside this part of the bearing and permit some misalignment. So why this self-aligning ball and roller bearings are used? Because it tolerates some small misalignment between the axis of the shaft and the bearing, External surface of the bearing bush is made up of spherical, that means this curvature is provided, and the bush is free to roll in its seats and align itself with the journal according to the load and according to the misalignment. Try to understand. They are used in agriculture machinery, ventilators, and railway axle boxes are the classification of the self-aligning bearing. Now, in this session, I have not described you the taper roller bearing, and I am going to elaborate this during the session how to select a taper roller bearing from manufacturer's catalog. And you know very well, here in taper roller bearing, rolling element is having a taper shape or a form of frustum of a cone. They are arranged in a such a way that axis of the rolling element intersects as the common apex, and then it is going to take both radial as well as the axial load. Outer ring is called the cup and inner ring is called the cone. I will elaborate in more or discuss during that session or during that model. Okay, now let us see the materials used for the parts of roller contact bearing. Now you know very well, roller contact bearings consist of basically three parts. One is the balls, rolling elements. Second one is the inner race, outer race. The balls, inner race and outer race are made up of high carbon chromium steel, or you can say SE 52100 or AISI 52210. It consists of 1% of carbon and 1.5% of chromium. Balls and inner race and outer races are hardened through. In this case, balls, races and outer race are hardened throughout to obtain a minimum hardness of 58 Rockwell C. In case of balls, races. Again here, in rolling contact bearing, another component is the cage, but cage are made up of a low carbon steel, and in roller contact bearing or rolling contact bearing, the balls are replaced by rollers. And these rollers are made of case hardened steel. Now here high carbon chromium steel, here case hardened steel, or AISI 3310 or 4620 or 8620 is the material which is used for the rollers, but they are made up of case hardened. What is the main important point here? Balls are hardened throughout, but rollers are made case hardened. Try to understand and remember, this is very important point. And here case carburizing is done to obtain the surface hardness of 58 Rockwell C. Try to understand here thorough hardening of the balls and here case hardening of the rolling element or rollers. This is the basic difference. Otherwise, high carbon chromium steels are used for the balls races, maybe inner or the outer. Cages are made up of low carbon steel and the rollers are made up of case hardened steel. Here case hardened and for the balls through hardened. This is the difference. This is about the introduction of what do you mean by bearing, classification of bearing, and in general materials used for the parts of rolling contact bearing. Thank you. I have referred to Bandari's book, Design of a Single Element, 3rd edition, McGraw publication. If you have any query, you please WhatsApp me at this number 9890426679 or mail me at pbkushari@kkvag.edu.in. Thank you. Thank you very much.